What if we've been looking at the search for AGI? All wrong.
How do you mean?
Well, we always picture this massive fundamental leap forward, you know?
Right. A whole new architecture, some huge breakthrough in
Right.
processing power.
Exactly. But what if AGI isn't some expensive grand overhaul? What if it's just a better wrapper?
A wrapper.
A coordination layer built right around the AI skills we already have.
Ah, I see where you're going.
That tension, between the incredible skills of our current models and them just not having a proper manager. That's what we're diving into today.
It's the perfect way to frame it. Welcome to the deep dive. You sent over a fascinating stack of sources this week, and they all seem to be pointing in that same direction.
It really feels like the tech is finally catching up with the theory.
It really does. So our mission today is to unpack this shift. We're going to start with the rise of what's being called the agentic desktop.
And a new system from Anthropic, Claude Cowork.
Exactly, and what that means for your local files. Then we'll hit some of the industry dynamics, career moves, acquisitions, some pretty significant regulatory blocks.
All things that reinforce this need for oversight, for that wrapper.
And finally, we'll get to the big one. The theoretical breakthrough from Stanford that suggests our current LLMs are already pattern engines with the raw skills for AGI.
Okay, let's start there with the agentic desktop. This feels like a huge step.
It is.
For a while, we've had powerful tools. Think of Anthropic's last agent, Claude Code. It was amazing, but only if you were a developer.
Right. It was transformative for coders, but for most people it was inaccessible. Powerful, but frustrating.
Kind of stuck in its own world.
Yeah.
But now, they've repackaged that power into something called Claude Cowork.
And this is the significant part. We are officially, I think, entering the agentic desktop era.
Meaning, the AI is leaving the browser sandbox.
It's leaving that secure, controlled environment. Cowork wraps all that existing power in a friendly, approachable UI. So now non-coders get access to automation that used to require, complex scripting.
And what really sets this apart from a standard GPT agent is how it interacts with your local data, your files.
Deeply and directly. That's the essential technical jump here. It's using internal APIs to talk to your operating system.
So it's not just generating text in a little box anymore.
No, it's manipulating real-world digital stuff. We're talking about an agent that can organize your files.
As in rename, sort, delete.
And move documents across folders, all based on a single high-level command you give it.
So I could just say something like, draft the Q3 report, pull the sales figures from those receipts I scanned, and cross-reference them with the notes in my Google Drive.
And it would do it. It can draft that report from scattered notes, it can pull structured data out of a messy PDF, and it can use connectors to get into your Google Drive or Slack. It's like it's stacking these little Lego blocks of data from all over the place into a finished product. And crucially, it keeps you in the loop. It gives you progress updates step by step.
Like a real teammate would.
Exactly. It's the first real do-anything assistant that actually lives on your system.
It's the difference between having like a single wrench, a very specific AI tool, and having a whole workshop installed right on your computer. The utility just jumps exponentially.
That's a perfect analogy. And the sources mention that some of the alpha versions of these agents can run projects on their own for months.
Months,
and even build their own kind of functional identity over time.
Wow. Okay. So if these agents are running that long on their own, touching our personal files, what's the biggest risk here?
When an agent is touching a user's local files like that,
Yeah.
the primary danger is unintended data manipulation. That's why it demands really strict testing and very clear boundaries.
Right. And understanding those risks forces us to look at the bigger picture. Regulation, career growth, all of it.
Precisely. Let's pivot there. Because a tool like Cowork changes the required skills for a job overnight.
That's a great point.
Yeah, there's this great piece of career advice from a Google AI product manager. They said, be like a crab.
Like a crab?
I know it sounds a little silly, but the idea is that lateral moves are often the fastest way to grow in this field.
Ah, so instead of trying to climb straight up the pure AI research ladder.
Exactly. You find a role that bridges what you already know, healthcare, finance, whatever, with these new AI tools, you become the human part of that coordination layer.
That's really smart. You're leveraging what you already know to manage the new patterns the AI is seeing.
And even the older tools are still incredibly useful. Claude Code is great for data visualization. You can build these powerful dashboards from, say, Google Analytics data almost instantly.
So there's an efficiency gain there.
For sure. But there's also the opposite, right? The research pointed out that AI agents are often overused. People are spending a fortune on complex AI when a simpler workflow would have been fine.
Which brings us right back to the quality control problem, the AI slop.
His slop, yeah.
That robotic generic fluff that just fills up everything now. I'll admit, I still wrestle with prompt drift myself, especially when I'm trying to get a unique voice out of it across a long output.
You're not alone in that. That drift is a real-world sign of low reliability, but tools are starting to pop up to fix it. The notes mentioned an extension designed to help you write like a human again by stripping out that robotic language.
Okay, so that helps with the content side. But this coordination layer idea isn't just inside the machine, it's external too. We saw some big regulatory news that supports that.
Absolutely. The decision by Malaysia and Indonesia to block Grok. That's a critical precedent.
And the concern wasn't just hypothetical, right?
Not at all. It was explicitly about AI-powered deepfake porn. The governments basically said Musk's team wasn't doing enough to stop the tool from being used to, quote, unmask people.
So the regulatory block is a form of external coordination, forcing better ethical boundaries.
It is. And then linking back to this need for rock-solid reliability, we saw that big acquisition in healthcare.
Right, OpenAI buying Torch.
For about $60 million. And what Torch does is pull all this incredibly complex medical data, patient histories, test results into one secure central place.
And why healthcare?
Because if any field needs what we'll later call Zone 3 reliability with no fluff, no hallucinations, it's medicine. This shows they're getting serious about high-stakes applications.
Yeah, it all just keeps coming back to that idea of autonomy. It's hard to shake what you said about those alpha agents.
I know. The sources mentioned do-anything's alpha agents, systems that run autonomously on projects for months, and they build and maintain their own operational identities over that time.
Oh.
Imagine scaling a project to run on its own for months where the AI manages its own identity and trajectory without a human stepping in. That's a little chilling.
A digital identity just running on your desktop. Did the sources touch on the legal side of that?
Not explicitly, no. But the question is hanging in the air. If an autonomous agent causes harm, who's responsible?
That's the whole ballgame. But okay, back to the slap problem for a second. We need real ways to fight it, beyond a simple extension. How can users actively fight against that robotic content right now?
I think the best approach is to stop giving it generic prompts. Use very specific tools and, more importantly, constraints that force the model out of its easy default pattern matching mode.
Constraints, which is the perfect segue to the theory behind all of this. Stanford's research on the AGI pattern engine.
This is where all clicks into place. The Stanford paper argues that our existing LLMs GPT-4 Claude are already incredibly powerful pattern engines.
So they basically digested all of human knowledge.
Think of it like a massive digital encyclopedia. It can see billions of connections between concepts. It knows what to do.
But, and this is the key part, it doesn't reliably know when to do it. The skills are there, but the manager is missing.
Correct. So the missing piece isn't more data or a faster processor necessarily. It's what they call a coordination layer.
The expert librarian for the encyclopedia.
That's a great way to put it. It's a slower, smarter system sitting on top, picking the right patterns, enforcing the goals you set, and keeping track of a task over time.
But wait, are you saying AGI is basically just a glorified operating system? That feels, I don't know, a bit simplistic.
It's more subtle. The idea is that the potential for goal-directed reasoning is already baked into the LLM's structure. The coordination layer isn't just an OS, it's more like the executive brain.
The part that provides grounded decision-making.
And make sure the outputs stay consistent and relevant over a long period, which is where current models really struggle.
Okay, and the Stanford team found a way to measure this. The anchoring strength score.
Yes. Exactly. It's a score that measures how locked in the model is to a reliable answer. It's like its internal confidence meter. We need to know when we can actually trust it.
So how do you increase that score? How do you get a stronger anchor?
3 things. First, you give it crystal clear goals and constraints. The clearer the instructions, the higher the anchor.
Okay.
Second, the evidence available has to clearly point to one path over the others. And third, this is the crucial one, the anchor gets stronger when the answers stay stable, even if you tweak the prompt a little bit.
Because that shows real reasoning, not just mimicry.
Precisely.
So low anchoring strength is where we get the frustration, the prompt drift, the fluff, the hallucinations. The Stanford team laid out 3 zones based on this.
They did. Zone 1 is weak anchoring. That's just useless noise, pure slop. Zone 2 is the unstable middle ground. Small prompt changes lead to big, unpredictable changes in behavior.
But Zone 3 is the goal.
That's the sweet spot. Strong anchoring. That's where you get reliable, goal-directed reasoning, the kind of output you'd need for medicine or finance.
The implication here is just, it's massive.
Yeah.
It suggests AGI isn't this long, slow climb up a mountain.
It could be more like a switch.
You either cross that reliability threshold or you don't. The raw skills, that giant encyclopedia, it's already here. It just needs that smarter wrapper to get to Zone 3 consistently.
And what's so cool is this connects directly to your own experience. It explains why some AI outputs you get are brilliant, you accidentally provided constraints that pushed it to Zone 3, and why others are useless.
They're stuck down in Zone 1.
Because the quality of the output is directly tied to the quality of the management. And right now, that manager is you. It's the prompts you provide.
So if the skills are already here, what's the one practical behavior that will tell us we've finally crossed the AGI switch?
I think it's when that goal-directed reasoning becomes reliable across many, many different and diverse constraints.
Okay, let's wrap this up. What's the big idea to take away?
The big idea is that we're seeing these two threads come together. We have the rise of practical desktop agents like Cowork that are finally starting to use the raw pattern skills that Stanford's research has identified.
So the theory and the tools are meeting.
They're meeting. And the path to AGI might not be some totally new architecture. It might just be adding that crucial coordination layer, that executive brain, to the amazing pattern engines we already have. It's about management, not just memory.
And that idea changes everything about how we use these tools. It means we are a part of that first coordination layer when we write our prompts.
We are.
If you want to put this into practice and start building those strong, goal-directed constraints yourself, you should check out the Higgsfield Cinema Challenge. The deadline is January 24th, 2026.
That's a great way to get hands-on experience.
It's a fantastic way to practice prompt design with real deadlines and clear goals. By doing that, you are actively learning how to build Zone 3 anchors.
That's a really good point.
So here's the final thought we want to leave you with. If AGI is really just a smarter wrapper around the pattern engines we already have, what responsibilities do we, the users, have to provide the clear, goal-directed constraints that system needs to reach anchoring strength Zone 3?